I will eventually get caught up with all the grading that I have to do and get your test graded eventually. Let me go back to this page. As you can see, 2 weeks behind. Because we're in week 11 and I'm still on 9-3, which is in week 9. I don't know why that's there. Oh wait, I do now. That was 29. We're going to test, you'll have a test, I should say, over, it's 14, 8, and 9. And hopefully we can do that at the end of this week. And so how much I can get covered and how hard y'all can work. I need to get through 10 or 11 and 12, but when I get through 11, I'll be happy. All right, so let's look at, I have the right full screen up here. Let's look at section 9.3, which is slope-intercept. In order for me to write and this look like you can actually read it, look at my screen. The slope-intercept form. And we're talking about equations of lines. We're talking about we've been talking about lines. We've solved equations, linear equations, and now we're talking about these. The slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept, or where it crosses the y-axis. Okay. Sometimes you're given the slope, sometimes you have to find the slope. And to find the slope, you're given points x1, y1, and x2, y2. Your slope is equal to your rise over your run. And if we look at a graph, one that actually is not slanted, I wish I had grid lines in this. Because it's going to get. We have a line that's going my distance, I'm drawing a dotted line that connects 2 points. So this point here would be my x1, y1. And this point over here is my x2, y2. So this would be my rise. This would be my run. And the rise is associated with the y, and the run is associated with the x. So my rise would be the difference in my y's over my run, which is the difference in my x. That's the slope formula. They also use a house as an example. I like to use a hill we have a hill that you've got a slight rise to. Okay, not so slight of a rise. But if we put this right here, whoops, right here, and call this ground level. This is a drawing pad. I'm supposed to be able to draw with it. So this right here is ground level. And this point right here is at a height of, say, 12 feet. From this point to this point, which is where that ends, is 7 feet. Okay, my drawing's off because I can't draw. Said every math teacher everywhere. But my rise, or my slope, is going to be 12/7 because I've got a rise of 12 feet. For every foot I go, or for every 7 foot I go one direction, I'm going up the hill 7 feet. So, say for every 7 feet I'm going west, I'm going up 7 feet. Okay, or up 12 feet. And that's the, they'll take that down to a percent. Oh man, words, I hate them. They takes it down to a percent, and you've seen that the road has got a grade of 8%. That's what this means, you know. That's a pretty steep rise, overrun. But anyway. On something that I'm not struggling over words. So in this example, you're given the 2 points, -2, -1, and 2, 7. And so if I was to draw a graph, we're going to call this -2, -1. So this point right here, I'm going to call this point A. Well, this is point A, this is point B. And +2, 7. This would be point B. I'm even afraid to draw this out. That's point A. And this is point B. And if I connect these 2 dots, pick up a red pen and it draws blue. What color green? So I can pencil in a right triangle that connects these 2 dots. Okay. I can count. I'm going from -1 or -2 to +2. I got 1, 2, 3, 4 spaces I'm going. And if I go from -1 to +7, So I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm just counting somewhere. But there should be an 8 that I'm going up. So my slope should equal 8 over 4. And if I reduce that down, it should equal 2. Okay. So if I use my slope formula, y2 minus y1 over x2 minus x1. So this is my second point. So my x1, y1, my x2, y2. So y2 is -1 minus y1, 7. X2 is -2. X1 is +2. So -2. -1 minus 7 gives me -8. -2 minus 2 gives me -4. -8 divided by -4 gives me a +2. So there's two different ways we can find it. We can find the slope using the slope formula, or we can find the slope by graphing it. Okay. Now sometimes Hawks will have you look at the graph and determine the slope. So in your mind, you're going to make a little triangle connecting the 2 points. I can't really draw that on my pad, and it looks even bad over there. So we're going to use the slope formula because you're going to find it the same. I mean, you're going to have the same thing. So in this case, I'm given the point 1, 3, and 5, 1. Okay. So I labeled those backwards. It doesn't matter as long as you stick to it. I've got x1, y1, x2, y2. So with my slope, and sometimes slope is labeled as m, still means it's slope. So y2 minus y1, x2 minus x1. If you write this formula down enough, then you have it memorized. So my y2 is 1, minus my y1, which is 3. x2 is 5, minus my x1 is 1. 1 minus 3 is -2. 5 minus 1 is 4. I reduce that one, I get a -1/2 for my slope. So that means that my slope is going down. So if you have let's make that again. That slope, it goes up like this. You're having to kind of push your car. Okay. Most of the time my car's up there. So I'm giving it pushing, which means that I have to lay on the gas. This is a positive slope. It's putting. You ever heard that? The car goes put. All right. Plain joke. So if I got one that's going down, he's speeding down. You got to put the brakes on. So this is a negative slope. Then we have a horizontal slope. My car's just sitting still. It's not going to go anywhere because it's on level ground. This is a horizontal. It's this has a slope of 0. And then you have a vertical, which your car just kind of falls off of. This has a slope that's undefined. So we have a positive slope. That's where A over B is both positive. We have a negative slope where either A or B, one of the two has to be negative. And then we've got our horizontal, which is 0. So the y's are going to be 0. And it can be over any number, but it'll still be 0. And then we have our undefined slope, which is some number over 0, which makes it undefined. That's for vertical. So you've got 4 different kinds of slopes. So you got your positive, your negative, your horizontal, and your vertical. Now, looking at just the horizontal and the vertical, on the horizontal, I can have point A and point B, and I'm going to have point C and point B. My y's are going to be the same, okay? My x coordinate's going to be different, but my y coordinates are going to be the same because it's horizontal and it's crossing the y-axis at exactly the same place all the way across it. The vertical is my, let's see, I'm going to have A, I can have A and B again, and I'm going to have A, A and D. Okay, my x-axis, my x's are going to be the same because it crosses the x-axis at exactly the same point all the way through. So your x's are going to be the same. All right. This will make sense. I'll do an example. So for horizontal, I might have points -2, 3, and 5, 3. Okay, so if I was to graph this, so this is -2, my line would graph straight across right here. So -2, 3 would be right here. 5, 3 would be right here. We're crossing at 3, so the y's are all the same. So I do the y2 minus y1 over, y2 minus y1 over x2 minus x1. I have 3 minus 3 over 5 minus a -2, which gives me 0 over 7, which would equal 0. Okay, so my y's are the same. And I'm going to get a 0 on top. For the vertical, my vertical line might look like this. And I'm going to have points 1 and 3 and 1 and -2. So 1 and 3 would hit here. 1 and -2 would hit here. This is sitting at -1, or +1 rather. So my x's are. So then when I use my slope formula, difference in y's, so -2 minus 3 over 1 minus 1, I get -5 over 0. 0 on the bottom, it's always undefined. And if you're in doubt, you can take the 2 points, put them in the slope formula and find your slope. Okay, so have I confused you completely? Just a little bit? Let's look at the slope. We talked about the slope-intercept form a minute ago. So once again, it's y equals mx plus b. And then this is slope-intercept. Then we have y minus y1 equals m times x minus x1. This is point slope form. And then we have ax plus by equals c, and this is standard form. What you have to remember with standard form is a has to be positive, and no fractions. The other two, I can have fractions. My x can be negative, it doesn't matter. But with standard form, you can't have fractions, and a has to be positive. It has to be a positive a. B can be negative, C can be negative, but A has to be positive. So they've given me an equation. It's not in standard form because x is negative, or a is negative, but it's negative 2x plus 3y equals 6. And they want me to find the slope and the y-intercept. So I'm looking for the slope and the y-intercept. So the first thing I want to do is I want to get this, I want to put it in slope-intercept form. Okay. So I'm going to take my equation, negative 2x plus 3y equals 6. To get it in slope-intercept form, y equals mx plus b. I've got to solve for y. Okay. So that means that I want to add 2x to both sides. Now, I can't add the 2x to the 6 because the 6 doesn't have an x. So I'm going to have 3y equals 2x plus 6, and 6 was positive. Then to get y by itself, I'm going to divide each term by 3. Divided by 3, that cancels. 2 divided by 3 gives me 2/3. If it doesn't divide evenly, you want to leave it as a fraction. So 2/3 x. 6 divided by 3 is 2. Okay. So it's in slope-intercept form. So if we kind of pair them up, the 2/3 and my M go together. The 2 and the B goes together. So M equals 2/3. That's my slope. B equals 2, and that's my y-intercept. Questions? Let's look at another one of these. So they always run together. So this time they're giving me the equation x plus 2y equals -6. Okay. So again, I want to know what is my slope and my y-intercept. So again, first thing I want to do is I want to solve for y, because I want it in the y or slope-intercept form. So I'm going to subtract my x over. So that gives me 2y equals -x minus 6, because B6 doesn't have an x with it. It's minus because it was -6. I'm going to divide each term by 2. Those cancel. So I get y equals, now if there's not a number with x, remember there's always that understood 1. So -1/2 x. 6 divided by 2 is 3. So -3. And I'm going to compare it to my y equals mx. So my -1/2 goes with M. My -3 goes with B. So my slope equals -1/2. My y-intercept is -4. I didn't do this one. Okay. They want the y-intercept written as an ordered pair. So in the y-intercept, x is always 0. If I go back up here to this other one for my y-intercept, it would be 0 and +2. So your y-intercept is always 0 and B. Oops. So this is taking your equation and finding your slope and your y-intercept. The next part of this, we're going to kind of turn it upside down. I'm going to give you the slope. Tell you the slope equals (1/2), and the y-intercept is 0 and -2. Okay. So remember, my slope is always M. So if I use the y equals mx plus b, I'm just going to plug my M in, plug my b in. So y equals positive 1/2 x. Since b is a -2 or -2, negative is going to be a -2. So there's my equation. Okay. Those are the fun ones. Those are the easy ones to do. Questions? So sometimes they don't give you the slope and the y-intercept. They give you just 2 points, or they will. This is the first one. Good. This is 9.4 in the book. It's still 9.3 on the homework. So they give me a slope that equals a -1/2, and they give me a point 2 and 3 that the line passes through. So the line passes through point 2, 3, and it has a slope of -1/2. Now I can graph it with that, but I can't tell you what the equation is. Okay? If I have the slope, like we did a while ago, the slope and the y-intercept, I would use y equals mx plus b. But since this isn't the y-intercept, this is x1 and y1, I'm the slope. Y minus y1 equals m times x minus x1. So I'm going to plug these in. Y stays y. My y1 is 3. My m is a -1/2. X stays x. X1 is a +2. Okay. Now they want this one written in standard form. So I'm going to do the math on this first. I'm going to take the 1/2, multiply it to both terms. So y minus 3 equals a -1/2 x. -1/2 times -2 makes it a +1. We'll go ahead and add my 3 over. So y equals a -1/2 x plus 4. Okay. I want it in standard form, so I've got to have x and y on the same side. So I'm going to add 1/2 to both sides, 1/2 x. So I have 1/2 x plus y equals 4. And I also said that you couldn't have a fraction. So I'm going to take and multiply each term by 2/1 because I got a denominator of 2. So you're multiplying it if you got more than one fraction by your greatest common factor or common denominator, but I only have one, so I'm multiplying by my denominator. I'm multiplying each term by 2. So the 2's cancel, leaving me with just x. 2 times y gives me 2y. 2 times 4 gives me 8. So there's my equation in standard form. This is in slope-intercept form. This is standard form. And this is point slope form. Okay. So we've gone through all 3 forms to get to standard form. Just a matter of knowing the process. But the thing is, if you're given 2 points or you're given the slope and a point, use point slope form because it's point and a slope. If you're given the slope and the y-intercept, you can use the slope-intercept form. You can skip part of it. It doesn't always have to be written in standard form. Sometimes they'll tell you to write it in point slope form. Sometimes they'll tell you to write it in slope-intercept form. So you got to know what each three forms are, but where you can stop. So let's look at another example. So this time I'm given the point -1, 2, and 4, -2. So I'm given 2 points, and I'm told to write the equation of the line containing the 2 points. Okay, and again, they want it in standard form. But the first thing I have to do is I have to find my slope. I can't do anything without the slope. So I'm going to label these so we can keep them straight. This is x1, y1, x2, y2. So my slope formula is y2 minus y1 over x2 minus x1. y2 is -2, y1 is +2. x2 is 4 minus x1, which is -1. So -2 minus 2 is -4. 4 minus a -1, those come together and make them plus. So it's over 5. So my slope is -4/5. Then second, I'm going to use the point slope form because I have a point and I have the slope. It doesn't matter which point you use, you will still get the same answer. But since I've labeled them x1, y1, I always like to use the x1, y1. So y minus my y1, which is 2. My slope is -4/5. X stays x. x1 is -1. So then I have y minus 2. I'm going to clean this up a little bit before I distribute. So -4/5 minus a negative makes that x plus 1. Then I can distribute my -4/5. So I get -4/5 x minus 4/5. Before I waited till I had added my 2 over and had it as y equals, I don't necessarily have to. I can do this here. I can multiply, my denominator is 5, so I can multiply each term by 5, or 5/1, however you want to look at it. This 5 cancels that 5, that 5 cancels that 5. So I have 5y, 2 times 5 is 10, minus 4x minus 4. Then I want to get my x and y on the same side. So I'm going to add 4x to both sides. And in the process, I'm going to add 10 to both sides. So I get 4x plus 5y equals 10. I add right. I add 10 here. -4 and 10 gives me a +6. Those are a little more complicated because you got a few more steps to do. All right, so any questions? This stuff moves right along. All right, so we talk about parallel lines. Parallel lines are two lines that are going to run side by side. I mean, we can look in the classroom, the vertical lines holding the ceiling tiles up, those are parallel. And you can find parallel lines in the floor. The tabletops, the opposite sides are parallel. But the one thing about parallel lines is they have the same slope. Okay, they will always have the same slope. They'll have different y-intercepts, but they will always have the same slope. So I can say y equals 2/3 x plus 7, and y equals 2/3 x minus 7 are parallel, okay? One crosses the axis at +7, the other one crosses the y-axis at -7, but they're still parallel lines because 2/3 is the slope for both of them, okay? So our slopes are the same. This is the same. And perpendicular lines their slopes are what we call the negative reciprocals. So if one slope is A over B, the perpendicular slope, upside down T, Richter's is shorthand for perpendicular, it's negative B over A. Another way I can, if I have A over B times negative B over A, they equal -1. And so if you multiply your two slopes together, it'll give you -1. So if I compare lines, y equals 3/5 x minus 6, and y equals -5/3 x minus 6, and these can have the same y-intercept. They can have different, but they can have the same y-intercept, okay? So this one has the same y-intercept. But if I look at my slopes, this one slope is 3/5. My other slope is a -5/3. Well, it's a negative reciprocal. One's positive, one's negative. All right. If I take 3/5 and flip it to get the reciprocal, it's 5/3. So it makes it a parallel line. I can also multiply them together. 3/5 times 5/3, -5/3. And I get a -15 over 15, which gives me -1. So that's how you tell if equations or if lines are parallel or perpendicular on a graph. And it's also what we use to determine what the parallel line is or the perpendicular line. So in this example, I'm given the point 2/3. I want the equation of a line that passes through the point 2/3 or 2, 3, and it's parallel to 5x plus 3y equals 1. So again, the first thing I have to do is I have to find the slope, but I have to find the slope of my equation. Since it's got to be parallel to this line, I've got to know what is my slope of that line. So I'm going to find the slope. To find the slope, all I have to do is solve for y. So subtract 5x. So 3y equals negative 5x plus 1. Divide everything by 3. Y equals a negative 5/3 x plus 1/3. Well, the only thing I need out of this is my slope. Okay, so I just need my slope. I don't care about anything else. So I'm going to take my slope, and since it's parallel, I'm going to use it over here with the 2, 3 to write the equation of the new line. And I'm going to use the point slope because I know my slope and I have a point. So this was first, this is second. So I'm going to use y minus my y1, which is 3. My slope is negative 5/3. X minus x1, which is 2. Distribute. So y minus 3 equals a negative 5/3 x. Negative, negative makes that positive. The whole number 2 can be written over 1, so negative 5 times 2, or negative 5 times 2 is 10. 3 times 1 is 3. And I'm going to write what they wanted. They want it in slope-intercept form. So I'm going to add 3 to both sides. So negative 5/3 x plus, so if I add 10/3 and 3 together, I can either do it on a calculator, get a common denominator, 5/3 x. So if I multiply this by 3, I have 10/3 plus 9/3, which gives me 19/3. And then this is my equation of my line. Y'all look like I just wiped out your best friend. Either that or I'm so monotone today I'm putting you to sleep. I am pretty monotone today. I'm sorry. I just get in the zone. All right. So the only thing we're doing different here than what we did in the other examples is that we have to find the slope of that first equation and use it to write the second equation. Okay. I got one more thing I'll do and then I'll let you guys go. I have the same point, the 2/3, or the 2 and the 3. I have the same equation, the 5x plus 3y equals 1. So it's the same equation that I had up here, okay? So again, first thing I want to do, is I want to find the slope. Well, we found the slope a while ago. It's a negative 5/3, right? All right. So since this line is, it wants this line to be perpendicular, then to get my perpendicular slope, I'm going to change the sign. Since it's negative, my new slope is going to be positive, and I'm going to flip the fraction. So my perpendicular slope is 3/5. Okay. So you flip it and change the sign. So my new slope of 3/5 and my point 2/3. Again, I'm going to take the point slope form and write the new equation. Y minus y1, which is 3, my slope, which is 3/5, x minus x1, which is 2. Distribute my 3/5. I still have the y minus 3. So I have 3/5 x minus, I'm going to put that 2 over 1 again, so 3 times 2 is 6 over 5. Then I'm going to add 3 over. So I have 3/5 x minus 6/5 plus 3 over 1. I have to have a common denominator, so I'm going to multiply the 3 over 1 by 5. I still have the y equals 3/5 x minus 6 over 5 plus 3 times 5 is 15 over 5. So minus 6 plus 15, 9. Yeah. So it's going to be plus 9. Yes. There's my perpendicular equation. I feel like I've blown your minds for today. Are y'all keeping up with your Hawks homework? You having trouble with it? Okay. If you'll email me which ones you're having trouble with, I'll see if I can find something to help you. Okay. All right, so everybody got this down? Because I want to show you something that I haven't shown you in Canvas. If we'll go back to Canvas, stop sharing. I posted videos. So this is chapter 9 videos. This covers everything in chapter 9. Okay. Most of them are YouTube videos, or I think they're all YouTube videos. This guy, Brian McLogan, is really good. Okay, I've got a lot of his videos in here. Some of these others are just funny. Some of them are, I mean, they're funny, but they're good. I've watched most of these videos, or watched all these videos. But also have chapter 8 videos. So if you're struggling with chapter 8, you can go back up here and look at these videos. And these are all YouTube. So if we use, distance, rate, and time. So if she doesn't suit you, there's more videos over here. It's a word problems, distance, speed, and time. So you can go to somebody else. You can watch some of these other videos. If, I don't understand it with her. Here's the test prep. Some of these are really good. I didn't see that one earlier. I hate ads. I realize the importance of ads, but I hate ads. So some of these guys are nerds. Look at this guy. I mean, are really good. They're they're kind of funny and they'll keep your attention. This one had pictures somewhere. Evidently, it's not going to have pictures in it anymore. We teach it differently than what I do, so there's nothing wrong with that. But anyway, there's pictures and there's videos in YouTube. All you have to do is go to your modules and look under videos, chapter 14 videos, chapter 8 videos, chapter 9 videos. We did writing equation using the point slope form, 2 given points. We did that example, so there's one of those videos. I had parallel and perpendicular. I may have to go back finding parallel and perpendicular equations, but there's videos out there. You can Google or YouTube search parallel and perpendicular lines. So if you run into questions and I'm not around, or you can't get a hold of me. All right. So any questions about anything that I've shown you or again today? We all good for now? Till you start the homework, you're good, right? Okay. All right. Well, then I will see you Thursday. That's what I wanted to do. I want to hit stop video.